Every year, cybercrime extracts roughly $500 billion from the global economy. Attackers regularly lock hospitals out of their own patient records and drain municipal bank accounts, causing immediate physical disruptions to everyday life. When we hear about massive breaches, it's easy to picture a brilliant hacker typing furiously, shattering advanced digital defenses through sheer technical genius. The reality is much more mundane. Most attacks succeed because the software running our critical systems is riddled with basic, highly preventable mistakes. We have been building digital infrastructure on top of fragile code for decades. This happens because the technology industry's economic incentives point in the wrong direction. For 40 years, companies have competed on price, new features, and speed to market. Writing secure code is slow and expensive, making it cheaper for vendors to ship vulnerable products and let users deal with the fallout. This dynamic created the multi-billion-dollar cybersecurity industry. But that industry is essentially an aftermarket tow truck fleet, endlessly following behind vehicles that rolled off the assembly line with known defects. These everyday coding errors provide an open door for highly sophisticated adversaries. State-sponsored hacking groups explicitly target these basic software flaws to infiltrate physical infrastructure. Groups like Volt Typhoon and Salt Typhoon have used these vulnerabilities to quietly establish footholds inside American telecommunications, municipal water utilities, and the power grid. Fixing this is incredibly difficult because major utilities run on millions of lines of legacy code. Manually rewriting that aging software to remove deeply rooted weaknesses is so labor-intensive that it would bankrupt most organizations. By building heavy defenses on top of structurally broken software, critical infrastructure remains in a state of permanent vulnerability. The math of manual defense simply does not work. In April 2026, the AI safety company Anthropic announced a collaborative initiative called Project Glasswing. The project centers on an unreleased AI model called Claude Mythos Preview. This model can scan, analyze, and comprehend massive codebases at a scale and speed that surpasses elite human security researchers. When unleashed on OpenBSD, one of the most heavily fortified operating systems on the planet, the model located a 27-year-old vulnerability. It discovered a flaw that would have allowed an attacker to remotely crash any connected machine, a bug that automated testing tools and human experts missed for nearly 3 decades. The model then analyzed the Linux kernel and autonomously found and chained multiple vulnerabilities together. It mapped out exactly how an attacker could escalate from basic user access to total control of a server. Finding an isolated bug is routine, but identifying and linking exploit chains, without human guidance, proves the model can execute security operations historically reserved for the world's most capable human hackers. This introduces a severe dual-use paradox. The exact AI capabilities required to find and fix hidden software flaws dramatically lower the technical skill required for a malicious actor to exploit them. This creates a high-stakes race condition. Defenders have a brief window to deploy this technology before malicious actors deploy equivalent AI models to attack it. To maintain that defensive head start, Anthropic chose a controlled deployment strategy. Instead of releasing the model publicly, they restricted initial access to a specific coalition of technology and infrastructure providers. That coalition includes foundational entities like Amazon Web Services, Apple, Broadcom, Cisco, Google, and Microsoft. These organizations build the operating systems, cloud networks, and financial systems that run the global economy. When they use AI to harden their foundational code, the security benefits cascade downward to every user and organization relying on their products. The true breakthrough here is economic. By deploying AI agents to analyze and transform code simultaneously, the monumental cost of rewriting decades of fragile legacy systems suddenly becomes affordable. This allows organizations to move security upstream. Automated AI agents can scan codebases for vulnerabilities and propose patches alongside developers, fixing the code before it ever ships to the public. It is the digital equivalent of crash testing vehicles inside the factory to ensure they can survive an impact, rather than waiting to see what happens on the highway. Organizations will no longer need to purchase an endless array of aftermarket defense tools to compensate for defective software. They can operate on products that are measurably secure out of the box. Fixing code vulnerabilities addresses only one layer of a complex threat landscape. Phishing, supply chain compromises, and basic human error remain significant attack vectors that an AI code scanner cannot solve alone. To secure the broader landscape, government agencies must establish unified standards for secure software procurement across all sectors. This policy shift requires clear legal liability frameworks. Software producers must be held financially accountable when negligent design choices lead to systemic security failures. By securing the code itself, organizations can stop pouring billions into constant defense. They can finally reallocate those resources toward proactive deterrence. We are reaching the limit of what we can achieve by continuously defending flawed code. AI provides the tools to rewrite that foundation, marking the beginning of the end of cybersecurity as an endless aftermarket patch, and allowing us to build digital systems that actually deserve our trust.